Hello everybody, and welcome to example 2 on page 24 of the workbook. In this example, we are going to be looking at just part A. And let's read the directions here. So they would like us to, given the graph of a function f, to sketch the graph of the derivative f prime as accurately as we can. And what's interesting about this problem is that all we have is a graph. We don't have a formula for f. So this is all about graphical estimation and thinking about what the derivative is telling us about a function. How could we get started on this? Okay, well, what I like to do, one way to get started is to first ask yourself, are there any places where the derivative is equal to 0 on our function? Okay, and remember that derivative is about slope. So as you look at this function here to the left, do you see any places where the tangent line slope looks like it would be 0? Okay, and I see 3 points, here, here, and there. Okay, if we drew in little tangent lines at those 3 places, we're going to get 0 for our slope. Okay, and what that means is that the y value of the derivative has to match that slope. And so where those 0 slope lines are, we have to have 0 values on the derivative. Okay, there, there, and there. That's that correspondence again of the y value of the derivative matching the slope of our function. So that gets us started. Those 3 points that we just plotted are points on the derivative graph that we're trying to draw. Okay, and now what we're going to do is kind of look at the graph of f one piece at a time. Okay, starting with the piece over here to the left. Okay, when you look at just that stretch of the graph, if you were to draw tangent lines along that stretch, would they be positive sloped or negative sloped? Okay, I'm just going to draw a few in. Notice that the slopes of all those lines are negative, and because those slopes are negative, that means that our derivative graph has to be below the x-axis. Its y values have to be negative. So what we know then is that over to the left of this first point, the derivative graph has to be below the axis. Okay, maybe something like that. Okay, and I don't know for sure how low it goes. All I really know is that it's below the x-axis on that stretch. Okay, next part of our function graph we might look at is between here and here. Okay, so if we drew in tangent lines on that stretch, would they have positive or negative slopes? Well, let's draw a few. Notice that all of those slopes are positive. And since the slopes are positive, that means that the y values of the derivative have to be positive. So they've got to be above the x-axis, meaning that between these 2 points, the derivative graph has to be above the axis. So maybe it looks something like this. We know that it has to go through these 2 points and be positive in between. Okay, we just kind of keep doing this. So the next zone of our graph would be from here to here. And if you draw in tangent line slopes there, notice that they're all negative, which means that our derivative graph is below the x-axis. Okay, so maybe something like that. Okay, and then finally we come to the very last stretch of f. Notice that the tangent line slopes there are positive, and so the derivative graph has to be above the x-axis. It's got to have positive y values. Okay, and so maybe it looks something like that. All right, and so that red graph that we drew is our best approximation of what the derivative graph should look like.